I'm talking about multi-car dispatching. How can I move forward? I know it works. Okay. When I'm talking about a multi-car, I'm talking about that multiple cabins are sharing multiple lift shafts, and they use one shaft to go up and to use another shaft to go down, and they have the option to exchange between the two shafts. To get an impression about such a system, I would like to show you a short movie about a 1:3 scaled mock-up what is running in Spain, just to get an impression about the technology. Here you can see on the left side, cabins are moving up. On the right side, they are moving down. You see it's a backpack solution. So the lift guidance is in the back. You see the rotation of the guidance of the lift, and that enables the cabin to move horizontally. You also see some garages on the left side. That's only to show the technology a little bit. It's just a random movement of the cabins. So what is needed when it's a ropeless system? We need linear motors. The coil units are in the back of the shaft, and the magnets are mounted on the cabin. If there's no counterweight, it makes sense to have a lightweight cabin. There we saw the lift guidance and the way how to exchange cabins between shafts and have the horizontal movement. And of course, we need safety. All these topics are not really the focus on this paper, but it gives us the basic technology to think about such a system. So last year, I was talking about using such a system as shuttle lifts. That means connecting main floors and sky lobbies, and the cabins are stopping all at the same floors. It's similar to a metro system where every train is stopping at every station and the trains do not bypass each other. It's a little bit different for buses. They can bypass each other, but usually they have also the same stops. When we come to local groups, when we want to bring passengers to their destination floor, it's more like a taxi. We have individual stops of the cars, and it's more like a shared taxi because not every passenger has his own taxi. When we talk about these local groups and this taxi behavior, it's important to look about quality of service. So we saw that picture before. The quality of service, it's traditionally the waiting time, it's the transit time, it's how full the cabins are. And so I guess Richard said a lot of about quality of service before. And another thing, when we think about quality of service, is we need to think about the lift behavior itself. How does a lift serve the calls? And there are some widely accepted rules. Do not bypass a car call or a destination of a passenger. I think no one would expect that. Do not transport passengers away from their destination. That deals with reverse journeys. I want to go into detail in that presentation. But it is less critical when we have a one-way traffic in a shaft and only stop off a floor because of a car call or a hall call. And it's not the first time I refer to these rules, but it's the first time I can refer to the work of Kloss. Thanks to Gina, now I have access to this work. Thank you. So these rules apply for this taxi approach, and each car has its own shaft or road. And the rules are still true and apply to a system where multiple cars are sharing the same shafts, the same, and are circulating, and we have a one-way traffic. But if we have multiple cars sharing the same shaft, we need to think about additional rules. And one thing is more the extension of the rule 3 I mentioned before. We could stop lifts when there's no passenger inside the cabin. So the rules are there to meet the passenger's expectation. And if there's no passenger, we have more freedom in the operation of the lift cars. Another thing, we heard that also from Richard's presentation before, the departure delays. When you look to this little animation, this passenger has to wait inside the car before the car above, because the car above is blocking the way. So why do I say we should reduce it? Another option would be to avoid it. Of course, if we avoid it, it would meet the passenger's expectation. But in traditional lift groups, in an up-peak situation, it's a built-in concept to delay the departure of cabins if the cabin is not full. So that's the reason I said we should reduce it or keep it to a minimum. And another thing deals more with the allocation of calls to cabins instead of the behavior of a lift itself. And it says an arriving cabin at a landing opening its doors for passenger transfer shall answer all hall and landing calls allocated to that landing call. So what does this mean? I have a picture here. We have two passengers. And if these two passengers are allocated to this left system, to this red door, both passengers will enter the next arriving car. What is this one here? So this can be achieved with a conventional control and a destination control. The advantage of the destination control is that we can group passengers together in different cabins. What is when we are allocating both passengers to the same shaft door, but the right passenger is for the next cabin, and the left passenger has to wait for the cabin that arrives after the next cabin. And how can this be? How can that work? So we need some kind of display. To be honest, I'm not sure at the moment if this is possible. Maybe in future it will be more possible when new devices are used for a passenger guidance. It would be interesting to hear what you think about that. Actually, we know that concept from trains or from the metro. And there it's clear different lines are stopping at the same platform. There it works. Does it work for lifts? So I'm happy to hear what you think about that. Another thing is the handling capacity. The handling capacity in that multi-car lift system where multiple cars are circulating is defined by this cycle time, the time between two subsequent cabins, two following cabins. And here we can see the position over time of two cabins, just an example, and the time between the cycle time. And a minimum possible cycle time is defined by the stops of the cabins. In that case, it's a shuttle application. Every cabin is stopping at the same floor. So we can achieve that minimum possible cycle time. But when we come to a local group where we have this taxi approach, every cabin could have individual stops. And here again, the position of cars over time, we have the blue cabin stopping, let's say, at every floor, the same stops for the red cabin, and in here we can have this minimum possible cycle time. What is when the green car it does not have the first stop? If we would have the same cycle time, that would lead into a traffic jam or something like that. So that means we need to increase the cycle time, and increased cycle time means a reduced handling capacity. So from traditional lift groups, we know a behavior of the lift group like bunching. That means all the lifts are arriving at the main floor at the same time. If we had the same behavior in a circulating multi-car lift system, we would end up in traffic jams at the end. So we need to avoid this bunching or the traffic jams, and we need to deal with the different number of stops. And this is just an example that all these three cars are, let's say, well distributed, and we don't have a bunching here. And so there it works for a circulating multi-car system without the irritation of any passengers. So what can be done for this synchronization of the cars? There's a difference between if are passengers inside the car or not. If they are in the car, we can have flexible speed patterns, just use a slower speed to make sure that a cabin does not catch up. Within ranges, we can modify the door opening and closing time. Sure, there needs to be a limit that the door opening is not too slow. And the same thing can be done with a flexible door as well. We have additional options when there's no passenger inside the car, because then we can do things without considering the passenger. And as Richard said, we are not moving boxes, we are moving the passengers. But when there is no passenger, we can simply delay the door openings, because I think passengers are used to wait outside the lift, but when they have to wait inside the lift and the lift doesn't start, it's more frustrating. We could just have the additional stops. That's according to this additional rule. We can just delay a departure. We can use something like a middle exchanger, so that not every cabin needs to go completely to the top floor to exchange to the other shaft, so we can shortcut the round trip. And another thing, below the lowest landing, we can have a passive area or a stock where that a cabin is located inside that area. That means the cycle time does not depend on the next arrival of that car. So because the next car is already available, and this area can be used to delay cabins. So in the paper there are some other topics. Due to time, I do not go in detail about safety distance between cabins. We need to think about the segmentation of the linear motors, the dispatching. It's not only like traditionally the assignment of calls and the behavior of the car. That was part of the presentation of the dispatcher interface. We need also this loop or system control for the synchronization. it's what's also mentioned in the paper is a 3-car system, 3-shaft system. Does a 3rd shaft help for handling capacity or not? And also mentioned is a circulating multi-car lift system with an express zone. How does a multi-car lift system needs to be designed when there's an express zone? In that case, there's no higher speed necessary to achieve handling capacity, what is needed. I come to the conclusion. I want to say 2 things. When we have a multi-car lift system, we need to think about the passenger and the passenger expectation and the quality of service. And another thing, I would like to invite you to make your own conclusion. We are close to lunch, and we will have a buffet outside after the photograph, and we will have different stops at the buffet. And everybody will have different choices, what he will pick, and he will have different stops. And maybe when you are standing in line and for the food, you think about how many stops is the one before me doing, and how many stops is the one behind me doing? Do I delay something? So just check when you go to lunch. So enjoy your meal, and thanks for listening.